Okay, good morning. Welcome to
Calculus 28.
Calculus 28. So we're studying partial fractions right now, and someone on Twitter yesterday mentioned if you're studying partial fractions, you should learn about something called the Heaviside cover-up method. And I actually didn't know what it was, but it's a way that allows you to solve for the coefficients. In certain cases, pretty quickly, which is neat. It's a nice little time saver, but it's also a very cool piece of math. So I thought I'd talk about it today. And we had talked yesterday. This is one of the problems in your book, and we worked through the algebra. What would you say about the algebra on this one?
It's a little messy, but it's not too bad.
Right, it's not too bad. It took. I still have it right here. It took 2 pages. I tore one of them out already. So, and, we worked through it. But I'm going to have you do this one as an example in the next video. But first, I'm going to show you how the method works. And I'm going to choose a slightly easier problem so I can fit it on the board without a lot of problems. So let's say we wanted to do 2 over y squared minus 1. And this would be a over something plus b over something. What are the 2 things?
It's y minus 1 and y plus 1.
And here, one thing we might do is cross multiply, find the coefficients of the y's, find the constant coefficients.
Mm-hmm.
Let's factor this side 1 minus 1. Y plus 1. But there's actually another really interesting thing that you can do. So if we want to find a, multiply everything on this equation by y minus 1. Okay, so when I do that, what does this side become?
It becomes 2 over y plus 1 equals a plus b times y minus 1 over y plus 1.
Okay, and when I do this, what value of y can I use to find the value of a very quickly?
Y equals 0 would probably find it pretty quickly.
Okay, what would y equals 0 turn into?
So this turns it into 2 equals a and then minus b.
So have we found the value of a?
No.
No.
Maybe we want to use 1
Okay.
to get rid of the b.
Yeah, so when I plug in 1, what do I get?
So you get 1 on this side equals a equals 0.
And then this goes away. So if I multiply by y minus 1, the fraction in the denominator there, and then plug in y equals 1, I get a. And that's pretty interesting. I get a equals 1. What do you think I can do to find b?
If you plug in y, if you multiply by y plus 1.
So I get 2 equals y plus 1. I may as well use the fact that I know what a is now. Y minus 1 plus b. Oh, sorry. 2 over y minus 1.
So again, putting y equals, y equals minus 1 in this case.
Okay.
So you get minus 1 equals b.
So there's not a lot of algebra. This particular one, the algebra wouldn't have been that difficult, but it's actually quite a time saver in some other problems. What is the problem? There's a sort of secret little problem hiding here.
Well, you're multiplying and then plugging in a value that makes the thing you multiplied equal to 0.
Okay, and why is that a problem? Go back a step in the equation. Why is plugging in, say, y equals 1 or y equals minus 1 in this equation a problem?
Well, that can result in Well, you're multiplying each side by 0,
Yeah.
which is generally not. Generally doesn't work.
Yeah, so in this equation, y equals 1 and y equals minus 1 are not actually in the domain of the function.
Mm-hmm.
What do you think's going on here? So what's happening? What do you think's happening mathematically that makes this work? Giving the correct answers.
Hmm. I guess since you're doing the same thing to each side, that you can simplify. I mean, these are definitely not the same function,
Right?
but maybe the relationship of like this function to this function is somehow similar to this function to this function, or something.
Yeah. Yeah. So one thing we could do is we could just do the algebra that we did originally. The other thing we could do would be something like this and sort of take limits and find that it's kind of the limit as y, in this case, y goes to, what was it, minus 1? Goes to minus 1, and look at what this equation does here. Now the limit is y goes to minus 1. As long as y is not minus 1 and near minus 1, this is always defined. So we would find something here. So that's sort of the intuition why this would be sort of okay. This side of the equation is fine. If this holds in the limit, it probably holds here. But there's a little work you have to do to show that. But it's nice. It's a nice technique, and it's you gotta be a little careful that you plug in the right numbers.
Mm-hmm.
But nonetheless, it's, I think, worth knowing. So let's have you do the problem that took us 2 pages yesterday, and see if you can get the same answers.